We are now going to continue with our discussion of nullclines. You'll notice that the first term in each one of our equations is a logistic growth term for that species. And the second term in each equation has interactions between x and y that are negative, which tells us that this is a competing species model, since both of the interaction terms are negative. Now, we're going to find that it's helpful to rewrite these equations just a little bit. So I'm going to multiply by 2, but leave the x out front. So they get x times 2 minus x minus y. And then in the second equation, I'm going to multiply by 3 and leave the y out front. So they get y times 3 minus y minus 2x. And now I want to look at the nullclines. So first I'm going to look at where dx dt is equal to 0. So x times 2 minus y is equal to 0. That tells us either x is 0 or y is equal to 2 minus x. And if I plot that, let's see, I'm going to plot x equals 0. And then I'm going to plot y equals 2 minus x. And those are the two x nullclines. I want to move on to the y nullclines. I'm going to choose a different color here. So the y nullclines are where dy dt is equal to 0. So I have where y times 3 minus y minus 2x is equal to 0. So either y is equal to 0, or we can have that y is equal to 3 minus 2x. So y equals 0 is the x-axis, so I'm going to plot that. And then 3 minus 2x, I'm going to start at 3, and it should cross the x-axis at 3/2. And now I need to figure out all of the equilibrium points. These are the points where both dx dt is equal to 0 and dy dt is equal to 0. So I'm going to start by looking at where dx dt is 0, specifically at x equals 0. I'm going to plug that into the dy dt equation. And when I do that, I'm going to get y times 3 minus y minus 0 is equal to 0. That's going to tell me that y is equal to either 0 or 3. And that gives me two equilibrium points, 0, 0, and 0, 3. Then I'm going to look at where y equals 0. I'm going to plug that into the dx dt equation. That's going to be x times 2 minus x minus 0. I'm going to set that equal to 0. That's going to tell me that x is either 0 or 2. And that leads me to the equilibrium points, again, 0, 0, but also 2, 0. Okay, and then we can see from there three of our equilibrium points. We can see 0, 0 on the graph. We can see 0, 3, and we can also see 2, 0. Notice that these are all points where the green y nullclines and the blue x nullclines intersect. There seems to be one more point right here where the green and blue lines intersect. So let's see if we can figure out that. That is going to be where y is equal to 2 minus x and y is equal to 3 minus 2x. So that tells me that 2 minus x is equal to 3 minus 2x. So x is equal to 1. If x is equal to 1, then y is equal to 2 minus 1, which is 1. So I get the last equilibrium point, 1, 1, which you can see on the graph there. Now, in the last lesson, we looked at classifying these equilibrium points using the Jacobian. But now I want to talk a little bit more about the x and the y nullclines.